Now, we're going to take part in the next industry session, Volumetric Video Capture. This is presented by Andrew Searle. Andrew is the sales manager at IO Industries, which is the manufacturer of the camera that we're about to talk about. Now, myself as a DOP, I'm incredibly excited about this new technology. This company is incredibly innovative. So now it's my pleasure to hand it over to Andrew.
Hi, good morning. As he said, my name's Andrew Searle. Thank you for the great introduction. I'm really happy to be here today. Hope you're enjoying the Forest City Film Festival. And today we're going to be talking about volumetric video capture. So my company, IO Industries, we're based here in London, Ontario. We're going to be talking about the technology that we're involved in with volumetric video capture. This is a presentation that'll be interesting for anybody who's doing anything with regards to immersive creation, content creation for AR, VR, or augmented reality, virtual reality. And what I'm going to start with is a background of the company, IO Industries, and then go into really what is volumetric video capture. It's a term that may be familiar to some, but it's still new and growing, and it's a great new technique for content creation. I'll talk about where it's being used, some of the great examples that we've seen it be used in over the last couple years, up to even recently, and then go into how it's created. So for the technical aspect, really go into what it takes to make this content. It's a very different technique than your traditional single camera productions. And then I'll go over what the volumetric capture ecosystem looks like today. So talk about some of the different players that are in the industry producing tools and techniques for this. And then go back to circling to IO Industries and how we get involved and what our portion of this is. And if you're interested in pursuing this, how we can help you with that. This is a variety of different slides, text, photos, and also some video. So I just want to be able to show you as many things as possible. Just to be clear that all the information is publicly available, and any trademarks you see are the property of their owners. So quick background on IO Industries. So we were based in London, Ontario here. It started in 1991. And we were involved in the early days of PC-based image capture and image processing tools. So we were doing solutions for medical, scientific, and defense-related research. And from 1998 onwards, we began designing very specialized digital video recorders. Very unique and capable of recording high bandwidth, uncompressed digital video using a pioneering direct-to-disc recording technology that we developed ourselves. This led us to then begin producing our own cameras and our own high-speed, high-resolution video cameras. These were being used in computer vision applications and multi-camera video recording systems. And this is really what brought us into the volumetric video application space, and it was a great fit for our products. Up to the point where last year we introduced a new product called the VoluCam, which I'll be talking about later on in this presentation. This is a new multi-format video camera. It has internal uncompressed recording, and it's really a combination of our existing strengths with video recording systems and camera technologies. So they all come together in this new product, and it's really been designed purposefully for volumetric video capture studios and the applications there. So it's something that's really come together with a lot of the experience and the information we've received from working in this space in the last couple of years. As of today, we have 20 employees. We're still based here in London, Ontario, out by the airport for anybody who's in the local area. We have everything under one roof. So we have all of our design and manufacturing all contained within our own design teams. We have electrical and mechanical product design, firmware development, software development. We get the boards produced and then do final assembly of the actual electronics at our facility, do all the electronic testing and final assembly, quality assurance, technical support after the fact as well. We still have a very broad market base. We cover applications still within the defense and aerospace marketplaces, scientific research, as well as this growing area for volumetric capture. You can see some of the examples of the groups that we've worked with, and more recently, in terms of volumetric capture, some of the very big names in the space, specifically with Microsoft and 8i, and then their respective licensee studios. So what is volumetric capture? Again, this is a term many of you may have heard of, or many of you may not have, and it's something that's growing in the industry. It's a new capture technique. It's a new way of capturing human performances and generating these really realistic, really lifelike, three-dimensional digital avatars of the human performer. What it is involved in is it takes a synchronized array of video cameras. They're surrounding the performer from all angles. And instead of it being a single camera production where you're just shooting from one angle, it's recording people from all angles at once, simultaneously. This gets then processed into what is called free viewpoint, three-dimensional video, or volumetric video. Compared to any kind of prior approaches that have been used to create digital 3D human performances for computer graphics, CG, it's a much more vivid, engaging, and realistic representation. Okay, there's a much more greater degree of immersivity, and it looks more realistic. The content that's produced with this technique is really ideal for very immersive AR and VR experiences, but also with traditional two-dimensional presentations as well. There's new 3D screen technologies. There's augmented reality using your smartphone, one of the most accessible AR devices that we all have in our pockets. But again, it's also being used in traditional two-dimensional screens as well. Key point to be clear about is, really what is it not? It's all about avoiding the uncanny valley, and the uncanny valley is this kind of a concept where it was, it was brought into to being with discussion about robots, and the difference between mechanical robots and then robots that become looking more like humans. There's a point to which, as you make a robot look more like a human, we start to like it more, and it's more pleasing to us. But then as soon as it gets to a certain point where it's closer to being realistic but not quite realistic, it gets to this uncanny valley where it's creepy, and it just becomes not very pleasing for us to see. And then past that, it becomes more realistic to the point where it's indiscernible of a human. So we've all kind of experienced this, where you've seen animated digital humans in film and television and all sorts of applications before. And to some degree, there's been a case where you could tell, that this has, been artistry at work to create this digital human. And in some cases, it's done better than others. But what this technique of volumetric capture is bringing is just a more accessible and realistic method for doing this, without requiring such intense amounts of computer graphics and artistry to get to that level of realism. But again, I like to use as much video as I can to help explain this. So what I'm going to do is show a quick video. It's very all-encompassing, and that helps to show exactly what's taking place here.
106 cameras, 10 gigabytes per second of raw data, and a whole lot of studio lights. This is how you make a hologram. Here at Microsoft's Mixed Reality Capture Studio, they're making volumetric 3D content to watch in virtual reality or augmented reality on the HoloLens. These cameras film the object or person standing inside an 8-foot circle, with 4 microphones pointing down to record audio. Half of the cameras are infrared to capture details of shape and texture, while the other half are RGB. Just like a regular film set, the director shouts action and the capture process begins. Footage is then reconstructed into a mesh, so post-production studios can change the lighting, manipulate colors, and integrate the hologram or 3D model into their content. Even though the system captures data at 10 gigabytes a second, the finished mesh is compressed to 10 megabits per second, so it's manageable and can be streamed more easily.
Yeah, so that is a great quick introduction to how this works. You could see that there was this specialized capture stage, a lot of cameras surrounding the performer. They create a capture, and then all the data from all those independent points of view gets reconstructed into a solid three-dimensional representation, or a hologram. And that's then freely viewable from any angle, just like you could inside any sort of three-dimensional space, like a game or something like this. It's just that it's now captured with realistic information and pictures of the person versus having to be drawn and created from artwork. And just so you know, I will be taking some questions, some Q&As throughout the presentation, and what I'll do is I'll address them kind of one at a time at the end, and then we can kind of have a conversation about that. So there's a couple different approaches for volumetric capture as far as like how it can be created, and it really can be generalized into two categories. There's two areas and two ways that it can be done, and it has to do with how the end deliverable comes to being. I'll break these into two categories, which I call real-time volumetric capture and post-processed volumetric capture. Real-time volumetric capture is kind of a bit of a holy grail right now, because it's the same sort of thing that you'd expect to have when you talk about like the holodeck on Star Trek, or you talk about being able to realistically interact with a 3D person that's located somewhere else around the world, and have these conversations with this three-dimensional person through your HoloLens or any type of AR screen. It's for low latency interactive conversations, or holoportation. This is still something that's very processing and bandwidth intensive. As you can imagine, there's a lot of information that needs to be processed and converted into this holographic asset in order for it to be then displayed in this way. And any kind of limitations that you put on this in terms of latency requirements, or being able to deliver very quickly, it really can impact the perceived realism, because the first thing to go is usually the degree of picture quality. And you can have these solutions where you're having real-time volumetric capture, but then you're going to start to see maybe some blips if there's not a good network connection, or if the processing is not keeping up quick enough. And I mean, this is something that there's a lot of research going into right now. But for now, the majority of activity is in what's called the post-processed volumetric capture space. And this is where, like I have shown, performances are recorded, and then there's a bunch of time, relatively speaking, to process that, run all sorts of algorithms to compute this three-dimensional model, refine it, and then deliver it. So that's a big difference, and that's the space that we primarily play in. Again, there's all sorts of growing research to develop a real-time solution that's also photorealistic, and I think we're going to see that in the next couple of years, if not sooner. But it's just a matter that right now, for the top level quality, the best degrees of realism and immersivity, people are turning to the post-processed approach. So where have we seen this? So there's been a couple of really interesting immersive music performances. And this has really hit home, actually, this past year. Of course, being unable to go see live music performances, artists are trying to find a new way to reach out and connect with their fan base. So these productions can be put together where the interested people that want to watch performances from the musician can actually see this from the comfort of their own home. You can use your screens of your AR devices, or your goggles, or anything like this, and actually feel like you're at a concert, right? The missing link that's there right now. Immersive marketing campaigns is something else that's been again strongly used. If you can imagine, from a marketing perspective, it's all about keeping eyes on the screen and keeping your interest for a certain period of time while you present some sort of a product or something like this. Really interesting case was you can see the Dallas Cowboys stadium on the bottom there. This was a partnership with Samsung, where with specific Samsung phones, if you went to the stadium, you could use your phone and look around, and you'd see these gigantic versions of the players kind of burst out of the roof of the stadium and do certain things. So it physically drove people to go to this event and actually be there and use their Samsung phones. So it was a big success for them for that. On the bottom right, you can see there was a winemaker in California who created this sort of interactive experience. Again, you use your phone and you scan a bottle of their wine with it, then all of a sudden the owner of the wine company comes out and starts talking to you, and it's a really interesting experience. And again, it drives interest, and it drives people to go to produce this. There's been a real amount of interest for 360-degree sports instant replays. And this is something that's come to light through several iterations over the last few years. If you can imagine the kind of effect of bullet time, if you could think back to what the Matrix did, and you being able to swoop around and see something from different angles, that's the sort of solution that's been brought to light from a group at Intel, with what they call their TrueView technology, and it's been deployed through football, baseball, basketball, and it's a truly new way of replaying a play, of the sports, and it gets you all sorts of different ways to see it. And again, it's used in a two-dimensional delivery. You still just see it through your normal live broadcast, but it's being pushed forwards to use greater network techniques like using 5G networks to effectively allow you at home to reproduce and see the play from different angles that you choose. And again, many people can see different angles that they want to see, because what's being streamed to you is this three-dimensional representation, not just a two-dimensional view that's happening to be replayed to you. So there's lots of really good interest in sports. And for that, I want to show another example, because again, it also goes through a little bit of a behind-the-scenes look, and I think it's a great way to capture why this is different from more traditional augmented reality solutions that have been used so far.
We always like to bring something new to the Open Championship, and this year is no exception. In fact, this innovation is a little bit extra special. It is the Sky Scope. Sounds complicated, but it's anything but. It's really cool, and it will change not only the way you view a player's golf swing, but the way they will, and also the way they'll work on it. Let's go and take a look.
That's where I hit from.
So this is where the magic happens. We've collected our club from the Pro Shop, and now we're into, well, the magic room of SkyScope. This is where we capture the images. You can see green everywhere you look, as well as a whole lot of cameras, 120 to be precise. So what's it all about? Well, it is volumetric capture integrated with motion capture. Sounds quite complicated, but what it effectively means is that we can now see in augmented reality, which means we can bring the virtual world into the real world. Now, you've seen that before in the open zone, where we do the tee times and the guys walk up alongside us. Well, they're not really there. They're on the practice ground or on the golf course already. This will take a massive gallery. Francesco Molinari alongside Tiger Woods. This one's different though, because this now means we can look at their golf swing and not just look at it in a traditional way, which is amazing for us, but also for the players involved. Let me show you what I mean. So they've come in here, they've whooshed away their golf swing, stood on this lovely little line. Very simple to do, very easy to do.
Start with the club on the X here. Eye line to that white piece of paper. Take a beat, step up to the line, do the address. If you step up to this line and pick your own mark there, basically. Action! And cut! Back in.
So that was Podrick going through the whole process, and in the end of it all, this is what you're left with. So this is my hologram in augmented reality, and it allows me to be able to look at my swing from so many different angles. You can see even by me just even crouching down, I get a very different look at my swing. So I'm looking at it from face on here as well, which is a really cool thing to do. But you say, well, I can do that normally anyway. What you can't do is obviously be able to change the focus, size of what I look at. But most importantly, and the bit I think is really cool about this, really fun for us to look at home, the ability to be able to turn the golfer around. One of the stars at Royal Portrush is Henrik Stenson, with open pedigree, a past champion and a great ball striker, one of the very best in the world. And we want to bring you a world's first right now in the open zone using SkyScope technology. And that allows me to take Henrik from out there and bring him in here with us now, and the opportunity to look at his golf swing from all angles. Never been done before, and a pretty cool way to see how he does what he does so well. Look how far the club head is still back of it. So he's released the head. So the old adage of, let's look at something we've never been able to do before, because, well, you'd never stand in front of a golfer, right, when he's hitting a shot. We can do that right now, and you'll see evidence of that release. He's having to go from a slightly open face in the backswing all the way to the finish now for us, Henrik. Absolutely beautiful, and everything you expect to see from a world-class player. Poise, balance on that left foot as well, posted up on top of it. A beautiful move, great rhythm, and he is without doubt one of the best players in the game.
So I think that's a great example, and that's why I like to show maybe the longer clip about that. It's providing a new way of seeing things that's never been seen before, and with photorealism, right? You can see that they were able to insert this three-dimensional hologram into the live stream of the broadcast there. Now that was a hologram that had been post-processed. It took about 48 hours from when the swing happened to when it was ready for use in the live broadcast feed, because there's so much data crunching involved. But again, that's technology that's increasing and making it better and faster every day. And thankfully that's something that we're having a part of with the improvements to our products as well. So again, it's a great way to show how this technology can be used in sports and bringing more reality to the review of those types of things. So what I wanted to talk a little bit more about too is some of the other areas. We've been seeing remote fashion events, so fashion shows. That's something that, again, this year has been impossible to participate in, just because of restrictions with COVID-19, of course. And it's something that's perfect in this situation because you can capture such great details. You can see realistic views of the person and they're performing as they would walk down a catwalk. It's just that they're doing it through a different platform, and it's really shown a great way for that. Telepresence, I mentioned about doing, having a CEO deliver a keynote, for example. That's a great way to get a better view and be more engaged with, your audience. Precision training and simulation, this is an area that really stands to grow a lot. And you can imagine, the adage of, going from a photo to show somebody how to do something to showing them a video to giving them an immersive three-dimensional, experience of how to do something. You're really going to drive home that learning and give them a better way to absorb it and then be able to understand it better. So precision training and simulation, we're seeing a huge amount of interest in from the enterprise space, government space, for example. You can see an example in the middle there where they had a doctor show exactly how to put on and take off personal protective equipment. And this was something that was used as a training aid. Nurses, and doctors got to, view this with their VR goggles and move around and get to see it from different angles and really understand what was happening at all times and replay it themselves a few different ways. So a great way to do that. 3D memories, this is something that's been thrown out there as well, and I think it's definitely got its place. You can have the concept of maybe like a photo booth maybe somewhere, and you go to this place and you can get yourself scanned or get one of your loved ones scanned and then have this three-dimensional capture of them to keep and hold for the future as opposed to just a photo or a video, right? So I think there's going to be a big place for that. And of course, with more regard to what we're talking about here at the film festival is cinematic virtual reality. So cinematic virtual reality, again, this is a way of experiencing productions in virtual reality or augmented reality that are, driven to the level of realism that you're immersed in them, like you would be in a film, in a two-dimensional traditional projected film. So one of the great examples that I like to refer to was in 2018, a production called Awake Episode 1, where it was about a 20-minute total production, so not very long format, but it was broken into sort of 9 different segments that you would participate in, or you'd be a viewer in the space by having your Oculus Rift or your other VR goggles attached, and you basically got to sit there and watch the performance and move around this room scale scene while the performances were happening, and really get to choose your own position and watch what's happening from any kind of angle you chose. And so I have a little clip for this as well, because it's something that really changed the landscape for bringing realism into this.
There you are, my dreamer.
Do you ever want to just sail away together?
I was discussing an alternative myth. I'll call it dramatic myth.
Why not start over right here?
This is the two of us. And we could weather just about anything, you and I.
The idea that life as we experience it's a big act.
Are you ready to come home?
And that behind this big act is the player. And the player
Wake up.
is you.
So this is still available. You can go into the online store and get access to this, and basically, you get to have this as an experience through virtual reality that's very different from many other type of cinematic experiences. And again, this is something that's growing. Just in the past year, there's been 2 prominent film festivals as well. Venice International Film Festival had a whole section called Venice VR Expanded. Vancouver International Film Festival just wrapped up several weeks ago, and they had a whole section called the Immersive Volumetric Market. And what they did was highlight the performances that are being put together using this technology and using immersive storytelling as a way to bring a new way of media to light. So here's a couple of examples, that were put out, and again, it's something that we see, really growing in interest, and I think that that's something that hopefully this crowd also will, understand and be able to think about using, for future productions. So now, how do we do this? How do we make this? There's a lot of different techniques, and as I mentioned, there's the real-time techniques, there's the post-process techniques, and even within that, there's a lot of different techniques as well. Different types of cameras. Fundamentally, it all starts with an array of synchronized video cameras. These can be uniformly distributed throughout the sphere. They can be grouped as stereo pairs, so that stereoscopic technology is used as part of the representation. But it ultimately has to ensure good coverage of the capture volume. The capture volume is then the space within that you can have one or more actors within. And generally we see this as a space of, let's say, an 8-foot volume. It can be as large as a very large 300-foot dome as well, but it all has trade-offs as to the degree of realism and quality you get to the number of cameras that you're going to need to capture that. So how many cameras are needed? As you can see in some of the representations, the number of 100 is thrown out. That's right now sort of the top end number that we see at some of the most premier studios, but it can be really no fewer than 12. That's about the most, or the fewest that you need in order to capture a full person from all angles. But anywhere in between, we see 30 and 60 pieces being used as well. It gives you maybe a little bit more issue when you come into having maybe 2 people captured at once. Big issue you have to be concerned about is just what's called occlusions, right? And it's making sure that you're not, you're always getting one camera at least to see, the surface that you're trying to image without being blocked by another person in the way or putting your hand in front of your face or something like this. So that's why having multiple camera angles really helps to solve that. Generally speaking, we're capturing video at normal video frame rates, anywhere from 30 to 60 frames per second. But for faster motion, there's sports and dancing and such where high frame rate video needs to be captured. So we're going beyond 100 frames a second or even faster. As you can imagine, it's all a matter of how many frames you have to process to deliver a result. So this leads to greater processing requirements. But if this is done well, having slow motion volumetric is really like it's a very dramatic effect, and it's again very great to see for in the sports replays, but it can be used as well in other ways. Generally speaking, the cameras are normally color video cameras. You can just imagine a normal type of video camera being positioned around a scene. This captures the color and the texture details that we would observe with our own eyes and provides a record of them from a certain point of view. But more advanced techniques are involving a layer of additional cameras, so another sort of capture modality. And this is where we use an invisible spectrum of light, so it's the infrared spectrum of light that we can't see and the color cameras can't see. What happens is structured or patterned light is projected onto the person. So this is the technique that's, you might have seen this before. It's been used in video game technologies with things like the Microsoft Xbox Kinect. This is a way of creating a shape generation, using a different modality than just RGB video. Sometimes the results that you get from computing the shape with just the color video are missing some information, and sometimes the same is true for the infrared information. So the true solution that's the best out there right now, does a combination of the both. You can augment, the two together, and then you get much more realistic shape detail, and you don't have the sort of the downsides of both effects. What kind of cameras are being used for this? Everything from consumer and prosumer video cameras, miniature action cameras are even being used in an array, moving up to industrial or machine vision cameras. This is the sort of the market space that we've come from. These are specialized, high resolution, high precision cameras, which are, different from a normal video camera because they don't tend to have video recording features inside. They're more for streaming video into a real-time processing system for, let's say, barcode scanning or shape detection of machine parts. And then the other approach that people are considering using and starting to use now are what's called depth cameras. And a depth camera is really just an all-in-one camera with multiple types of sensors. They'll have both RGB and IR type sensors with an IR pattern projector laser built in. And this is, again, the concept like the Microsoft Xbox Kinect. So if you've heard of the Intel RealSense series, again, this is the type of cameras that could be used for that. These cameras are ideally capable of a broader range of image resolutions than a typical consumer video camera. You can imagine if you set up an array of these normal video cameras that are shooting like a 16:9 HD format, you're trying to tile these in a way that creates a sphere of video. And if you have these rectangular sections in a sphere, it's going to be more difficult and a little bit off in one direction compared to having, let's say, square format, like 1:1 ratio or 4:3 ratio video. So that's where we're getting into dealing with cameras that have, again, off the normal path resolutions, which is, again, what our cameras specialize in. And we deal with resolutions on a per camera basis anywhere from 2 megapixels, which would be something like 1920 by 1080 video, to 12 megapixels, which is like 4K by 3K, so 4K but with a 3K vertical. And then even beyond, higher resolutions than that as well. And then the IR-specific cameras follow along the same resolutions as well. So then the data is created, it then has to be processed. So there's all sorts of different computer vision algorithms and 3D reconstruction approaches that are out there. And the goal is to take the imagery and derive a three-dimensional shape model, okay, from this. And in the end, instead of these two-dimensional pixels that you would then represent in a two-dimensional display, what you end up with are what's called three-dimensional voxels. Okay, voxel is the term for a three-dimensional pixel. It's a pixel. It's located in space, and it has, a color, as well as a shape. So it's a really interesting approach to doing this. Once you have that, again, you can then convert it to a polygon mesh. And a polygon mesh is just taking a solid object and representing it by a bunch of triangles. You get vertexes of the triangles, you get the shapes of the triangles. This is something that gets used a lot in video games, and that's why this technique actually lends itself really well to working in video game engines. So if anybody's done any sort of productions where you're working with video game engines, Unreal, Unity, this is, again, really tying into advancing CG by using these types of engines. Idea with the polygon meshes, the voxels, whatever. It's just that the greater number of them, the finer density of the details, the greater ability you have to represent fine details, in the actual representation in the end. So more data is better. You're going to get a better looking result, and those are where you make some trade-offs in the setup and the design of the system. There's still some challenges. This is still an evolving technology. There's still, again, some materials that are difficult to capture. You can see a result here of a 3D scan of an instrument, and you can see that it's not looking quite solid. There's a lot of information missing because there's some issues with regards to capturing reflective materials, right? There's techniques that can be done to mitigate this, but reflective materials can be an issue. Finely detailed clothing, lace, really fine repeating patterns in the fabric, that can become an issue as well, depending on the quality level of your cameras. Wispy hair, transparent materials are definitely an issue because it's tough to tell from a camera perspective that that's even there because it's transparent. But at the same time, some of the shape measurement techniques are detecting that surface of the glasses and then projecting that as like a solid block in front of your face, let's say. So there's some trade-offs that have to be made there. And any sort of mixed materials, water, smoke, and fog, that can be a problem as well. From a production standpoint, there's no standardized file formats, and you can imagine in post-production this can cause some issues. It becomes the fact that you have to deal with some more proprietary containers for the data and plugins to go into your your workflow programs. Again, solutions exist, but it's not quite as drop and go, plug and play as you'd see with more traditional two-dimensional video at this point. So who's out there providing solutions? The following is a good list of people delivering complete studios. So if you're a production company, if you're, let's say, an existing motion capture house, and you want to augment your solution and provide volumetric capture as well, then you can work with these types of companies who will deliver a complete solution. They'll have the capabilities to, really have, the solution delivered to you all in one. But at the same time, there is, again, the bits and pieces you could do this yourself with. So one example is, again, just the 3D reconstruction software. So if you had an array of cameras and you wanted to take the video and convert it into volumetric video yourself, and you didn't want to have necessarily like a full turnkey package provided to you to do this, you can use off-the-shelf software from a variety of different groups. And two to highlight right now, ModTech Labs and Volograms, they're really producing some great tools and techniques. You can upload your video to the cloud. It'll get processed there, so you're not having any sort of on-site requirements for that. And then the final delivery to you is a 3D model. There's other tools from the photogrammetry world, like Agasoft Metashape and reality capture, and those can be augmented as well to produce this motion video. And then you have to edit the tools. So you might be used to using traditional nonlinear editors. Well, that's kind of different now because you're dealing with volumetric. So you're kind of positioning a virtual camera in your two-dimensional delivery, if that's what you're doing. So there's tools to do that. HoloEdit, SenseXR Studio, Houdini, and Maya, just a couple to explain. And then, of course, deployment platforms. How are you going to get this out to the market? I mentioned that Unity and Unreal, again, those are different game engines which you can produce a deliverable with. But there's also people that are pushing it more, so you're not dealing with having to go and actually make an app, let's say. 8th Wall, for example, have plugins to then have this be something directly in your browser on your phone. It's really a new way to get this type of content without having to have special plugins to the end user. So it's a great way for distribution to become more easier. And then if you're not looking to set up your own studio and you're thinking maybe I just want to produce a production with using this volumetric, then what you're going to do is you're going to talk to a volumetric capture studio. And again, this is just a short list. There's others out there. These are some that we've happened to be lucky to be involved with. Some are based on the Microsoft platform that have many cameras, and some are based on other techniques as well. So they're all over the world. They're popping up several different new ones even in the next coming few months. So it's something that you're going to definitely see and learn that is available and more accessible to you over the next year for sure. So then some of the groups that are doing more in-house research, again, Google, Canon, and Sony, they're kind of pushing the limits on what the technology will get to, so you can keep your eye on them and see kind of what the new things they are coming out with. So kind of getting back to IO Industries a bit, again, we came from the place of making these specialized cameras. We would call them machine vision style cameras, and they were being used with our video recorders, two pieces together, to produce this solution for people. But we found that we needed to produce something that was going to make it a little bit easier. There was still some higher degrees of complexity to what our products had. They weren't necessarily designed for the purpose. And we wanted to bring something to market that brought a bridge between the more easier to use off-the-shelf commercial camera that's just got everything built in, internal recording and everything, to something that has all the extra features that a machine vision camera has. And that's what brought us to develop the VoluCam. So the VoluCam is our brand new camera. Again, it's an all-in-one one-piece design. We're really happy that it's come to market now. It's got a lot of great features and technologies. Lots of different sensors to choose from to have different resolutions, different frame rates. It's got built-in raw, uncompressed recording, so you're really getting top quality, best pixel data information to then go and process, compared to using a commercial video camera and having an MP4 file come out and then having to process frame by frame with that. We all know that that's not the best possible data to start working with. It's a really scalable technique and a solution that makes it easier to set up anywhere from 10 to 100 cameras or more. We provide really easy to use software for it. So it's really something that we're happy to have on the market today to help grow and expand this volumetric capture solution for the world. This camera came out last few months, and we already have our very first studio that's using it. This is Avatar Dimension in Ashburn, Virginia, DC area. It's something that's really targeting a lot of the government and commercial space education and simulation training applications, but again, also very much focused on commercial productions and creative content as well. So in summary, as IO Industries, we've had a lot of great experience over the last few years working with some of these industry leaders, pushing the limits of this technology in the AR/VR space. And our background in the technology that's involved has really led us to develop great solutions for it. We're happy to just be in the conversation with anybody that's talking about volumetric video, because it helps not only us but also some of our partners. And it's a matter where we just would like to talk to anybody that's even thinking about using this, and help to make connections even to some of our partners for it. I'm really hoping that after this discussion, you'll have a better base of understanding for volumetric capture, what it is, what it takes to create it, and just to get your ideas going about how could this potentially be used in some sort of productions in the future. The applications that I talked about are just a selection of many creative and innovative ways that this volumetric video technique is bringing realistic human performances to life, in immersive viewing environments. So really happy to have had the chance to talk about it. If anybody has any questions, please feel free to reach out to us. The easiest way to do that, just send us an email, sales@ioindustries.com. Happy to have follow-up conversations with people. And again, follow our social media. There's lots of interesting stuff on that as well. And we'd love to hear from you. So what I'll do now is just kind of quickly look through some of these questions. Thanks so much to the people that submitted them. So here we go. So first question, with LiDAR being one of the new things that are on smartphones, do we see any kind of integration with volumetric? And yeah, the answer is yes. LiDAR is a great technique. It's bringing the availability to people for shape capture, right? LiDAR is a method of creating a three-dimensional shape model, and then you texture that with information from a normal RGB camera. So LiDAR is definitely a technique that's being brought more to life, and definitely with smart cameras. The concept still is really good for detecting your position in space and detecting the space around you, maybe positioning three-dimensional objects within your space. But for capturing of a person in a performance, it's still a case where you need to view them from many angles at once. So we're talking still about needing like a way of synchronizing that type of camera and synchronizing it with color type cameras. So it's definitely something people are talking about, and yeah, it's a tech to be watching for sure. Someone asked, who is currently using this tech in Toronto? It's available. Is it available in Southwestern Ontario? How can we get access to it? So right now, at the moment, there's nowhere in Southwestern Ontario that's doing this. It is something that we've heard some rumors about something in the next few months. At IO Industries, we're actually putting together our own capture studio as a demonstration system. So in the next couple months, we're actually going to be coming to have this available and roll this type of thing out. It's something so we can show off really what our cameras do as a portion of the overall solution. But stay tuned, as far as our announcements about that, because that'll be right here in London, one of the first volumetric capture studios really in Canada. Can you tell us a little bit more about augmented reality, and is it being used widely in our region? Absolutely. Again, and I think I might have covered again some of the applications about this, but augmented reality in comparison to virtual reality, that's usually what the question is how is that different? Augmented reality is a matter of not just using goggles to cover your face and see just what the goggles show you, but using some sort of a transparent screen, whether it's your own phone and you're using the camera from your phone to see the rest of the world, but then having virtual objects or people brought into that scene through augmented reality. So you're augmenting what's really in front of you with something that's not real. And it's definitely being used in our region. We're seeing it used all over the place with your smartphones and the kind of apps and the interesting things you can use. There's a group here in London that's producing augmented reality experiences where you go around London and see different animals and things like that. It's definitely something that you should be checking out. Yeah, definitely. How does volumetric capture deal with more contrasted video? Do you need subjects to be softly lit for volumetric to be more effective? Yeah, the lighting has to be very uniformly leveled as well as very soft. You don't want to have a lot of reflections. You're trying to completely capture them in a unified lighting way from all angles, and then what happens is you actually do relighting after the fact. So if you've captured a really good object, you captured your person very realistically, then what you're able to do is then augment the light after the fact once it's inserted into the sort of virtual reality space. So yeah, the lighting is super important, has to be uniform, soft, and bright. Yeah. It seems like this technology is more effective in post-process, but could it potentially be used for live events like live concerts? Absolutely. It's definitely something which is being pushed on, and it's something I'd mentioned before as well. The issue right now is just bandwidth and then processing. Especially for live events, there's a bigger interest. It's the issue with the real time is usually with interactivity, right? If you're having a conversation with somebody, you can't have latency and lag. If it's a live event, even when it's broadcast to television, it's not live and it's not the same time that you're seeing it that it's happening in the real world. There's a delay. And so there's a toleration for a certain amount of delay as well for if it was to be transmitted as volumetric video. So it's just a question of improving that. There's a lot of development with regards to the 5G technologies, actually a lot of interest from the telecoms themselves to push this 5G technology forward. So their own research labs are helping to push this forwards to help bring more capability to the 5G networks and show you this capability. So live sports, but definitely live concerts. That's something that a lot of people have asked us about. How expensive would it be to put together a feature-length project using this technology? Good question. That's something that would be probably best suited to talk to one of the commercial capture studios about. Frankly, we don't really have a good idea of what that would cost. It's going to be a project that's in partnership with them. I would recommend just reaching back to some of those commercial capture studios, and if anything, we can help make a conversation get started with that as well. You mentioned the uncanny valley as something to be aware of. What's the best way to avoid issues that can arise with this technology and the uncanny valley? Well, again, I think inherently in a way this technique is trying to push away from the volume, the uncanny valley. It's trying to give you this photorealism from the get-go. You're already starting by looking at like photography quality representations of the person as opposed to a solid computer-generated asset or a model like that. So really, there's not going to be so much of an issue that the viewer is going to see and think that this is not the real person that they're looking. There's almost an immediate connection that you're looking at a real person, you're seeing their performance. However, any improvements that can be made to increase the realism through better, pixel density, streaming frame rates, and better, compression qualities are just going to make it look more and more like you're standing in front of the real person and seeing their performance. Is this technology a realistic option for independent filmmakers to use? Absolutely. As I mentioned, there's been a few different short films produced. This is something, again, there's a lot of different scales to how the technology can be put to use, and the requirements for cameras scale as well as that. So it's something where I would recommend looking at some of the entries in the film festivals that I mentioned, and just kind of looking at some of those just to see what's been done and the sort of the scale to which the production had. There isn't any studio listed in Canada. Is there plans on having a volumetric mobile studio in Ontario? At this time, you're right, there's nothing in Canada per se, but yeah, I think there's something that will be brewing over the next 6 months for sure. Do you think that this technology can enhance Hollywood directors' storytelling capabilities? Yeah, I do for sure, because of with the example of, again, immersive virtual reality, not necessarily augmented reality, but with virtual reality, you have so much more creative control over the entire scene about what's happening. It's also, again, I kind of go back and forth about having it be used in delivery of three-dimensional content versus 2D. When you look at 2D content, sometimes there's just sort of the impossible shot. You want to integrate this shot, and you want to have this camera that's flying around a person in an action scene or something like this, and it might not just be it just might not be feasible to do in a traditional shot way. Whereas capturing it in volumetric and then inserting it after the fact, you have more creative control to position it and edit it, and you'll get a more realistic result in some cases than if it was done through CG. Can this tech be cross-integrated with virtual sets being used on shows such as Mandalorian? Absolutely. Yep, it's something that's already being researched right now. There's some virtual set stuff being done for live sports broadcasting right now, where they're actually bringing in two-dimensional green screen captured athletes that are located around the world and bringing them into a virtual set at a specific location where the broadcaster is. And the idea being, if we can bring that into more volumetric, you get an even more realistic result than what's being done with just the two-dimensional virtual sets. The issue with virtual sets is just that it's a lighting source on its own, so it's going to impact the lighting on the objects, and whether that can then be counteracted in the lighting that's needed for capturing the volumetric person, that's the question. There's no doubt that virtual production is bringing a new technique, and it's also tying in with the same tools like the game engines, and being able to bring in a volumetric captured asset into that edited environment after the fact is something that could be definitely taken more advantage of. What's my favorite project I've been a part of using volumetric capture technology. I think really the golf example was what really drove it home. Personal interest there, but that was last summer, July 2019, at the Open Championship, and it was just so great to see it start to finish, working with the team that put that together, and then watching it happen in real time. It was just really great to see that. But again, more and more interesting things are coming out all the time, so it's pretty cool. Last question is, which major sports league was most open or excited to using this technology for replays? That's a good question. I think the one that's seen the most, initially I think it was football, but I think basketball ended up being the most interested. I think with basketball there's a bit more control over the lighting, being in an indoor environment versus the football. It was a little bit more challenging. But yeah, I think overall, yeah, it was great to see for both of them, and we'll have to see where else it can be used. Maybe we'll see it in hockey. That would be pretty cool. So I'm pretty sure that's it. I think that's my time. Once again, thanks so much for participating and taking part here and listening in. I hope it's been interesting, and if you have any other questions, feel free to reach out to us at IO Industries. We'd be happy to talk more about it. Thanks so much, and enjoy the rest of the film festival.